Okay, so the current question is a question which involves integration and a simple concept of limit. First, let's uh, investigate the given function. The fx is a piecewise function when x belongs to 0 to 1 open bracket. Fx is x by sin x, and if x is 0, then fx is 1. We know that x by sin x is a increasing function by application of derivative, as double derivative of this function is cos x tan x minus x upon sin square x, which is greater than 0 for all x belongs to 0 to pi by 2 open bracket. So now what we have to do is to evaluate this integral. Let's first plot the graph of this fx. After putting x is equals to 0, the fx gives 1, which means this is 1, and open bracket 1, when we substitute here, it's 1 by sine 1. So the graph is like this. We can easily say that the fx is less than 1 by sine 1 and greater than or equal to 1, because fx is a bounded function. We can at least conclude that. Now what we have to do is just to manipulate this inequality to get to the answer. The first thing we can do is to analyze the integral. We can see that the e raised to power minus nx is a positive number, so we can just multiply it in the inequality and it won't change the sign. Then after multiplying it with the inequality, it will be e raised to power minus nx, same with the fx, same with the 1 by sine 1. Now the limits of this integral are 0 to 1 by n, and we can just make an integral here with the same limits. E raised to power minus x dx 0 1 by n e raised to power minus nx fx dx less than 1 by n 0 e raised to power minus nx sine 1. We can see that this integral is become closer to this integral. Now to make it completely the integral in the given question, we just have to multiply the root n. Now after multiplying the root n everywhere, root n, it's a constant, so it will be out of integral. After evaluating this limit, this will become under root n e minus nx by minus n 0, and this will become the en, so I will just write the in. It will become this, and it will be evaluated into e raised to power minus nx by minus n. Now after evaluating and substituting the limits, what we'll get is e raised to power minus 1 1 minus under root n, same with this and same with this, minus sine 1 under root n. Now the question asks us to find limit n tends to infinity of the when the integral is this. So to find this, we have to put the limit in the whole inequality. Hmm. Minus under root n in and n tends to infinity e minus 1 minus sine 1 under root infinity n. Hmm. Now what we can see is n tends to infinity and n is in denominator. So we already know if there is any constant and denominator is infinity, it generally tends to 0. So we can definitely conclude that this thing and this thing too is 0 and 0. So 0 is less than or greater, less than equal to limit x tends to infinity in is less than 0. So we can see that the limit exists and it is 0. So the correct option will be B. Thank you.